Okay, in this video, we're going to take a look at the practice test, problem 17 through 22. Starting on this first one, number 17, it says, given that x is normally distributed with a mean of 200 and a standard deviation of 10, we want to find out z-score of 2.2 corresponds to what test score. So remember the picture that we have in mind. As soon as we see that something is normal, we can go ahead and draw our normal curve. Somewhat normal. And in the middle is always 0. That's the mean. Then here we have 2.2, which of course is to the right of 0. So we know that whatever test score this is going to be, is going to correspond to something that's greater than 200. So again, we're looking for the test score that corresponds with 2.2. So we do have a formula here. We have x equals mu plus z times sigma. So here mu is 200 plus 2.2 times 10, which of course is then going to be equal to 200 plus 22, which is equal to 222. So we can see that that matches up with our answer on the practice test. All right, number 18, it wants to know what if the z-score negative 1.5, what test score that corresponds to. So now we're over here to the left of the mean at negative 1.5, and we know that this is going to be some grade less than 200. So we use that same formula, except for instead of 2.2 for z, we put negative 1.5. Of course, that's going to be negative 15. So we're subtracting 15 from 200, which will give us 185. And we can see that matches up with our answer. Now for questions 19, we want to go the opposite direction. So now it's like we're given, I'll just erase this whole thing, I guess. So now we're given a score of 215 and want to know what z-score that would correspond to. Remember, in the middle for the average or the mean, we have 200. So which corresponds to a z-score 0. So we know this is going to be a positive z-score. Okay, so we have a different formula for this one. For this one, there we go. We're actually going to use z equals, then we're going to do x minus x bar, and then we're going to divide that whole thing by sigma. Okay, so here we have the point 215, or the score 215, and we'll subtract 200, and then divide that by 10. So we'll have 15 divided by 10, which of course is 1.5. Again, this is a positive z-score, so that falls in line, and it matches up here with our answer. All right, number 20, it's the same thing, but now we're dealing with a test score of 180. So again, let's use a different color. We know it's going to be somewhere over here to the left of the mean. And we know that this z-score is going to be negative. Okay, so we use our same formula, except for instead of 215, we put in 180, which of course is then going to give us a minus 20 on top, which will give us a minus 2 for a z-score, again consistent with the z-score being negative, and that does match our answer. All right, in problem 21, we're going to take a look at the probability a test score is below 195. So let's go ahead and let me erase this. Okay. All right, let's draw a picture first. So here we have our normal curve. Okay. And again, in the middle, we have our mean. This is another color. So we're looking at 195. That's below the mean, right? And we'll be looking for the area to the left. So we already know that this area has to be less than 0.5, right? Because if it was exactly probability less than 200, it would be 0.5 since 200 is the median. So you can think of this written as the same way. What's the probability that x is less than 195? Well, here again, we are given an x, 195, and we're looking for the area to the left. So we're going to use the normal CDF function. And because we're dealing with test scores, we will have to put the mean standard deviation in. Now, the first parameter in this function, we need a lower bound. The general rule is as long as you're 4 standard deviations away to the left, that'd be significant or sufficient for a lower bound. So here the standard deviation was 10. So if you went at least 40 down, so 150 would work fine. It's a little extra. But you could even do lower. I mean, we could have done negative 100 here. That's fine. And then our upper bound would, of course, be 195. And then 200 is our mean. And 10 is our standard deviation. And we want to round to 4 decimal places. So I'll show this on the calculator here. So do second bars. Go down to normal CDF. For a lower bound, again, we'll use negative 100. Would be more than enough. For the upper bound, we'll put 195. And then for the mean, 200, and the standard deviation of 10. Oh boy. All right, upper bound 195, mean of 200, and standard deviation of 10. There we go. All right, so that gives us 0.3085. Oh, it's right over here. 0.3085. Okay, so for number 22, it says given x is normally distributed and 200, standard deviation 10, z-score that corresponds to 25% of the data being below it. So remember, 25% of the data corresponds to 0.25 of the area, and of course it's below, so it's to the left. So given the z-score, or given the area, we'll use our calculator inverse norm function to find the z-score. So we don't know what this is right here, but we do know that this area over here to the left of it is 0.25. So again, that's going to be z equals inverse norm and 0.25. Now, usually we'll round the z-score to 2 decimal places, but here I did say 4, so I'll just leave it at that. We could do second vars, go down to inverse norm. Again, put 0.25 in for area, and mu and standard deviation is 0 and 1, and we can just leave that. So here we get negative 0.6745, rounding it to 4 decimal places. So negative 0.6745, and that should correspond with our answer, which it does. All right, so that's problem 17 through 22. If you'd like to see some more, just send me an email. Thank you.